And so yesterday we really hit a lot of the fundamentals of if statements, and we covered, if I really at a high level, what we talked about was if blocks, if else blocks, if else if comma else if, and they can go on and on, else if else, and that's about as far as we made it. Today the topics are going to be nested ifs, switch statements, ternary operator, and that's going to be good for this hour. Maybe we'll steer off. And so where we can kind of start, where this little C# GUI is we got a username and an age, and we can use that for this example. A button that says click me, that takes me to an event handler or an event listener to handle that button click. And so since we have a username, I can get the text username.text into a variable. And since we have a text box for the age, of course that needs to be converted. So we can kind of start here. Convert to int 32. And so yesterday when we were learning if statements, we might have written something like if age is less than 21 and username, there's an equals method, but I think not equal to boss, right? So if you're under 21 and you're not the boss, if you're under 21 and not the boss, you could do something, and we were compounding our if statements together. That would allow us to write an else block that would say, okay, well, if you're over 21 or you're the boss, label result.text is you're not welcome inside. But if you are 21 years older or your username is the boss, label result.text welcome in. And so that kind of led us where we were yesterday with an if-else statement. And again, if the username is Evan and the age is 20, you're not welcome inside. However, if you're 20 but you're the boss, and this is case sensitive, by the way, notice capital B, you're not welcome inside. Lowercase b, we are welcome inside. Okay, because we are the boss, we get welcomed in. Also, if my name is Evan and you're above 21, you're welcomed in. But again, going back to here, we're not, and this is where we were yesterday. A nested if statement, might you need a nested if statement? Well, it depends on the flow of potential outcomes. And so depending on the outcomes, and this is really where in some cases it helps to learn about flow charting and understand what are all the potential outcomes of a given scenario and when do you hit those outcomes. And so if I kind of change this scenario and say, okay, well, if you're under 21, you're not welcome inside. Here I could say, I can change what happens inside of this if statement, and I can say, well, here if username is boss, double equals boss. If username double equals boss and you're under 21, maybe we say, okay, you're welcome in the office, else label result.text, you're not welcome inside. So if you're under 21, now we test if the name is boss, you're welcome in the office, otherwise you're not welcome inside. What nested if statements just allowed me to do by breaking that other piece out of this outer if statement, it allowed me to have more complex inner workings of this if block. It essentially allowed me to have different outcomes. And so this is one example of a nested if statement. So if your problem that you're trying to solve is complex, maybe you need those compound ands and ors operators on the outer if statement. Maybe, depending on the flow of potential outcomes, maybe you need nested if statements to solve the problem. Now, the important thing that I want to point out here is notice that everything inside, everything that's nested is tabbed over. So I can tell what belongs inside of this outer if because it's all tabbed over. Okay, this allows me to kind of line up, well, this if statement belongs to this else block. And I can see that mainly because of how it's tabbed over. Okay, so to kind of back up here, when you start having nested if statements, the reason you do that is because the needed outcomes of that scenario, of that problem that you're trying to solve, dictate that. Again, if you're not familiar with flow charting, it's kind of this process where you could say, okay, if number 1 is greater than number 2, then you're doing this particular operation. Flow charting is a picture that you can kind of draw to help you understand the flow of what needs to happen in all the potential outcomes. Okay? And you get that, you generate that flow chart by understanding the problem and all the potential ways that it can branch out. Some computer science courses, when you have, when you get to this point, they have you flowchart. They have you solve the problem on paper to understand all the potential ways that the program could go. Okay, we don't really do a whole lot of flow charting because in most, in most of our cases, they're not that complex. But if you get a complex problem, doing some flow charting can help. So that's nested if statements. Next topic, and I'm going to hit switch statements, but to hit switch statements, I'm going to back out just a little bit, and let me just gather the user's age, and I'm going to kind of write a little block of code based on the user's age, and this will help you understand switches. I can say if the age is 0, label result.text is you are a newborn. Else if, pretty simple, age is 1. I can say you are an infant. Else if age is 2, we're going to call you a toddler. Else, label result.text is, I'm going to say, I don't know how old you are. So this is kind of something that we touched on yesterday. If you paid attention, you would understand kind of the conditions that are being tested against here and their potential outcomes. Of course, just coming into here, if I put in the age of 0, you're a newborn, infant, toddler, 3 or 10 or 100, it's just going to say, I don't know how old you are. It's not one of the other 3 conditions. And so that's one way of writing this code. Part of the challenge of learning this if, else block of code is that these scenarios can get fairly complex. I mean, you start testing a lot of different variables for a lot of different conditions. This structure right here can become complex. But it doesn't always have to be. In this case, this isn't a complex scenario. You're testing pretty simply for like a number, and that number is either 0, 1, or 2. And so there's an alternative way of writing this block of code that's a slightly more condensed syntax. And so it's a little bit easier to look at is what it really boils down to. Once you understand what a switch statement is, and that is a switch statement kind of replaces one of these structures. If, else. Okay, so I'm going to write this same block of code. I'm going to comment that out, and I'm going to write it in a switch statement. So the syntax for this is to switch on a variable. And so this is the variable that we're going to test. We're going to test the age variable. And then you write what are called case statements. Case 0 means you're testing age to be the value of 0. And if it is a value of 0, we will say label result.text is you are a newborn, just like we had before. Now, it says it cannot fall out of switch. And so what you need here is this keyword break, and then that compiles. I'll explain that, what a break will do for us. But now we do a case of 1, label result.text, you are an infant, break, case 2, what do I say, you are a toddler, and break. And then you have what's called the default case, which is the false block. The default is your false block, just like an else. Label result.text is I don't know how old you are. And so a switch, now the syntax is different, but in simple scenarios where you're just testing like a variable for a solid one, number, it was the case historically. There was a big difference between if else blocks and switches. Okay, that's not really the case anymore. But it used to be the case that switches could not test for ranges. So up here I could say if age is greater than 100. Well, there's a lot of numbers greater than 100, and you could test for a range in an if statement. And you could not do that on a switch. So like notice here, it's like case 0, case 1, case 2. There's no ranges. There was not a case, greater than 100. Okay, this kind of syntax is something that's newer to C sharp, and you can do this kind of thing now, but you can test for ranges in your switches that, again, used to not be the case. Let's just demo this and show you that it's essentially the same program. Functionally 0, 1, 2, 3. 0, 1, and 2 worked. There's skip 2, and there's 3. Because it's newer to C sharp, testing for ranges, talk about these newer syntaxes for switches. It is a syntax that I'm actually a little less familiar with. C sharp switch range of numbers. Let's just see the syntax. Now, there's what you could do, and this is kind of the next step. So you could say case 3, case 2 and case 3 and case 4, we're going to say you're a toddler, right? So for these 3 individual numbers, all 3 of them, you would get the output, you're a toddler. Let's demo that. 0, 1, 2, 3. 3 is a toddler again. 4 is a toddler. And then as soon as I hit 5, I don't know how old you are. It's also the case if you've ever tinkered with Java. Java allowed you to not have these break keywords here. And there was actually a certain behavior called falling through. And that's legal in Java. That's not legal in C sharp. So these break keywords prevent what is known as falling through. Falling through can be a desirable effect, but it confused a lot of people. So they say, you know what, no more. It's kind of like, hey, as soon as you hit case 0, you execute this line of statement. The break essentially says you're done with the switch. Okay. In other words, there's no fall through in C sharp like there is in other languages. So they kind of make that a hard rule. To go back to the, what do you guys do? Do you accept all cookies when you hit this stuff, or do you guys reject all cookies? I accept it too. So here's an interesting thing. In C sharp 7, switch statement using a range of operators. So we're switching on years of experience. 0 is inexperience. And I greater than and I less than or equal to 2. Level is beginner. So this is kind of a syntax that you could use. Now, again, I'm, I guess, more of a traditionalist. When I have ranges, I'm just going to use an if, else if block. Because that's kind of traditionally how it always worked. Then they start bringing in these arrows in C sharp 8. So these more modern syntax. This is not something you guys will need. If anything, I just want to expose you to it, that it is a newer feature in C sharp, which is a good thing. Okay, it's a good thing that Microsoft is taking a language that's been around for 20 plus years and applying some updates. Okay, now you might not need it for this class, but just being aware that it's a newer feature should you.
By the way, what C sharp number are we on right now? 8?
9. Yeah, it's 9. Yep. Yeah, the latest version is version 9. And so they've really kind of changed the syntax in recent years of a switch. And here's the most modern syntax. Again, you kind of take a look at this. We're assigning the variable of result equal to. Look at this. We're switching on the years of experience still, but it's formatted differently. The syntax is different. And we say, okay, 0 result will store in experienced. Greater than 0, less than 2, result will be beginner. Greater than 2 and less than 5, result will be intermediate. So it's not super hard. Anything else, like your anything, not anything else, but because obviously I don't like that, because to me, I believe this underscore means like a default case, which means you're an expert. And I'd hate to say, well, I guess you can't have -1 years of experience. It's got to be a positive number. So that would make sense, assuming you're validating against a positive number. All right. So that's kind of the switch. The switch statement itself has kind of changed in recent years. It's an alternative to an if, else if, else if, else if block. And even like I said, the syntax has kind of changed. So that's the second topic. So we talked about nested ifs. We talked about switches. And the third one that you will see in this class and in others, okay, is this ternary operator. Ternary operator, let's start with this. Ternary meaning 3, obviously. There's what are called unary operators. They're binary operators. Okay? And so if I have an example of int a equals 0 and I say a plus plus, okay? Plus plus is what's referred to as a unary operator. It is operating on one variable, right? Unary, singular, you're operating on one, okay? So the plus plus, minus minus, those are examples of unary operators. Binary operators, of course, they operate on 2. There's like really 2 variables that you're dealing with binary. We could say integer b equals 1 plus 4, okay? The plus symbol in this case is a binary operator because we're adding 2 things together, right? These 2 things are the reasons it's binary, right? So unary singular, binary is 2. Well, then, of course, ternary is 3. The ternary operator comes in this sense. It replaces the if-else, can replace the if-else block. Well, if-else is pretty simple. Yesterday I said if-elses are kind of like black and white. It's either true or false. Okay, so this ternary operator is going to replace an if-else block. Again, languages evolve, and so you can and we will see more complex ternary operators, but for now we're going to start with the traditional ternary operators, kind of like the traditional switch. We study the traditional switch, realizes that there's new versions of that switch out there. We're going to study the traditional ternary, realizing that it can be more complex. Okay, I'm going to say int c. I'm not even going to. I'll start with the condition. We're going to read the age. Okay, and we're going to say, is the age greater than or equal to 21? Question mark. So when you see this question mark, Not always, but in this case, it's going to be a ternary operator. It's the beginning of a ternary operator. Age is 21. If so, we're going to assign a string that says welcome to the venue. Otherwise, so colon, you're not old enough. Now, it doesn't like only an assignment call. Yeah, I need to assign this to a string. Result equals. Now it's happy. So I was trying to leave this string result off, and so we can assess this. This is our condition. This would be in the if block. Is the age greater than or equal to 21? If age greater than or equal to 21. If it is, then we're going to say welcome to the venue. And what we could do, label result.text equals welcome to the venue. No, it doesn't like that either. I didn't think I would like that. Trying something that doesn't work. Let's bring this back to what I had originally. String result equals.
Oh, would it not work even after you put the string result and then the label result text?
It'll work like this. So what we're doing on line 34, because there's a lot of pieces. We're testing a condition. If the condition is true, what comes after the question mark will run. If it's false, what happens after the colon will run. And then we store this string value. It is very common to take the results of a ternary operator and store that in a variable. So in this case, we're storing in a string because we're assigning the string equal to this or equal to that. And then we put it in the output. And again, if you're 21, welcome to the venue. If you're not old enough. So this ternary operator.
So basically like the if, else, and all that stuff is basically kind of like a cause and effect type of thing.
Yeah, you're testing something, seeing if it's true. If it's true, you do one thing. If it's false, you do something else. Okay? And so what we just talked about right here, nested ifs, I'm trying kind of like bring it back up, right? Because we're down in the weeds. We talked about three things today. Nested ifs might be needed in your programs when the problems become more complex. If there's a lot of potential outputs, right? Lots of potential outputs based on scenarios, you might need nested ifs. Switch statements can replace if, else, if blocks. Else, finally. I need to replace those with commas. So a switch statement is another syntax for if, else, else. Ternary operators can replace if, else. And so what we kind of touched on today builds on top of what we did yesterday, but we still have to practice what we did yesterday. So James kind of pulled me aside and he goes, hey, are we going to learn like best practices in this class? Coding best practices. And the answer was ultimately yes. We're going to talk about best practices and how, yes, you can code this 5 different ways, but what would be the recommended way? Okay, yes, we are going to talk about that. But for most people who are learning to code for the first time, it's about survival and just learning one way to solve a problem. I'm just trying to survive this class and solve this in any way I can. Okay, so I realize what I'm asking you to do is kind of like, hey, here's one potential way to solve it. Here's another potential way to solve it. Here's another, and those are all valid. They all could work. I just said, hey, these different things could replace these other things. And it's all out there. You're going to see all of this, right? So it is important to gain that exposure. But right now, for most people, it's about survival. I mean, we're in week 2 or week 3 of this class. It's very early. So I said, hey, I remember it's very much like this. When I learned to snow ski for the first time, I go down a little bunny slope, and I'm going down that slope, and I'm locked up, and I'm nervous, and I'm just trying to survive, right? For most people in this class, you're just trying to survive. Literally learning if-elses and if-else-if-else-ifs, like you're going down the bunny slopes, and we got to get you to the point where we can survive and solve it in one way. But then as you learn what is a switch? How does it work? You know, you might not need a switch in any of your labs. You might be able to get it by with if-else, if-else-else, and that's fine. You're learning. But I do want to expose you to these tools because you will see them. And certainly, as we evolve as programmers, we will use these. Right? So what I don't want to do is like start using them myself with an assumption that you know how to use them, but I've never taught them before. Right? At least now you have an exposure. Right? So, but once you get past that bunny slope, once you get past that I'm just trying to survive, then it becomes, okay, how can I be a little bit more efficient? So I really relate it to snow skiing because it's just an activity that at first you're trying to survive, and then once you get a little confidence, once you do it once or twice or 10 times, you get a little confidence, then you start, hey, how can I make this more efficient? How can I code this in the best practice? And those kinds of things. So everyone's at a different level, and you know, what we talked about today, some people might not be ready for this. If you can't code an if-else-if-else-if block, why code a switch, right? That's kind of like the next step. But it's in the chapter. It will be something that we code with, so I gotta cover it. Okay, I'm gonna stop the lecture there.